Hi guys, welcome to this video. This is Dr.M.MOORTHI, working as Assistant Professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So in this video, we are going to discuss about variable air-fuel ratio in modern engine. So this is a lecture series of automotive engines and emission control, where we have a series of videos related to the topic that going to be discussed. In this previous lecture videos, we have discussed about what is air fuel ratio, and then how this air fuel ratio will going to affect the performance of the SI engine, and then what is the standard values with the stoichiometric air fuel ratio, and then what are the further classification that depends on the quantity of air fuel ratio, then with the lean air fuel mixture and then rich air fuel mixture, and then the advantages and then disadvantages with respective air fuel ratios, and then how it going to affect or how it going to enhance the overall the performance of any spark ignition engine. And then after that we have the variable air fuel ratio. And then in the modern automobile industry, so we will get the what is required for our condition, our requirements. So we will get that. So that is the beauty of with our modern engines. So with the modern engines, it is automatically it can set or it can vary its air fuel ratio. That depends on condition where we are going to use this vehicle or where we are going to run this vehicle, and the type of fuel we are going to use, and then the environmental condition, and then the engine condition. So these factors will directly affect the ratio, air fuel ratio, and then based on these demands and the requirements, the engine will automatically going to adapt to those air fuel ratio. So with the adaptive engine management, and then modern engines use advanced engine management systems with the sensors such as oxygen sensors, and then to continuously monitor and adjust the air fuel ratio in real time. So with that modern engine, we have there's so many sensors are to be fixed in the vehicle, so you monitor the continuous process. And then with the oxygen sensor to be placed in the engine means where the quantity of oxygen, and it is the major reason we are getting the combustion process, how they directly affect the combustion. If we are having a sufficient oxygen during the combustion process means we get the complete combustion, and then fuel efficiency is more with the availability of oxygen high when compared with the engine. So that if the oxygen sensor is to be attached with the engine, while we have the changes or the deflection or variation, the sensor will automatically sense the quantity of oxygen is required to make the complete combustion process. So that we can the so we can automatically we are supplying or enough oxygen or the quantity of air, or it going to carburetor will directly adjust the air fuel ratio, or it suck more air into the chamber, and then we can make the required the air fuel mixture. So this allows the engine to maintain an optimum air fuel ratio under varying conditions. So the way depends on the condition, this oxygen sensor will sense, and then it gives the information, and then so that we can get the required air fuel ratio, and then feedback control. So the engine control unit use feedback from sensors to adjust a fuel injector, maintaining the stoichiometric ratio when the necessary, or switching to lean or rich mixers as required by the driving conditions. So this feedback system is attached, and then it continuously sends the feedback to, so that we can make or to can we can set the stoichiometric value as 14.7 is to 1, where 14.7 is the quantity of the air, and then 1 is the quantity of the fuel to be in the air fuel mixture. And then next, the air fuel ratio for a specific condition. So in the ideal condition, during ideal, the engine might use a slightly rich mixture around 13.8 is to 1 or 14 point is to 1 to ensure stable operation and then prevent stalling. And the next one is the condition of cruising. While cruising at a steady speed or we are applying the acceleration, a lean mixture around 15 is 1 or 2 16 is 1. So these variation or the range depend these the range is often used to enhance fuel economy. And then during acceleration and high load, when the engine is under high load, the rich mixture around the 12 is to 1 or 13 is to 1, where the quantity of air is high and then quantity of fuel is high, sorry, quantity of air is less, and then quantity of fuel is start increasing, and it used to give the maximum acceleration for the higher load application. So it is used to maximize power and then to protect the engine from high temperature. So that so depends on the condition, the modern engine and then modern vehicle will going to adjust its air fuel ratio and then its own. Thank you.